Hello everyone, I'm Zakaria. I'll be explaining you ICP 4. We had the same dataset that was presented in ICP 3 of big data. So that's a tweet sentiment analysis data where we have labels and tweets. Initially, we'll do some data pre-processing steps, and then followed by NLP algorithms, and basically training our model to predict. And obviously, its accuracy and loss values. Okay, so I've imported the necessary libraries, Keras and sklearn. Important thing, there's word cloud, and yeah. So I read the dataset from this given source URL. It starts again with the same @ of user. So the first step of the task was sort of repeated from the old assignment number 3. I'll just take you quickly over it. We had to remove @ of user. So tweet starting with @ of user, I defined a function and then run it over all the tweets. So you can see the clean tweet gets removed with @ of user and starting with these signs as well. Short words, then again, short words are basically those words with length less than 3. So I've just removed those as well. So you can see A is there removed. Again, unwanted punctuation, numbers, and special characters. So all those have been cleaned as well. Then I've tokenizing is basically dividing your tweets into sub parts. Like one sentence gets broken down into words, stemming them, and then putting the tweets back together. So this is our clean tweets, another data frame, one of the columns of data frame of our main data, which is the main data frame. Then I just quickly basically made a positive word cloud and a negative word cloud. Positive word cloud is basically where label is 0, and negative is word cloud is basically frequency of most repeated words, right? So if I just quickly explain you this is a word cloud of positive tweets, positive words. Positive words are words generated with label 0. So those words which have been frequently repeated are love, they, happily, thanks, smile today. And likewise, I can make this for negative tweets, right? So negative tweets will be the one with label 1. Okay. We are writing a function to remove hashtags, right? Clean those hashtags, and then basically I have wrote a function as well to basically count the number of hashtags, right? So we count their frequency. This is the distance is basically a function I made. Yep. So it actually counts the number of number of times the word has been repeated. So this is stored in a set as well. So it will contain unique values only. Yep, there you go. Okay, going down all the way. This was just checking, so printed. I have again, if I just want to present those hashtags, I've counted the hashtags right above here. So if I just want to present these hashtags in a bar form, in a histogram, so I can do that too with the help of these functions. So these have been plotted above, and likewise negative words have been counted top 10, and then they have been top 5 have been plotted with the hashtags. Okay, after pre-processing steps, I have again basically cleaned all those you can see delimiters, lower text, unnecessary words which were causing trouble in my data processing. So clean them, and I've got a much cleaner data with all those pre-processing steps. So now it's time to give it to my training. So I'm dividing the training and testing samples and give it to my machine learning algorithm to train and basically predict the results. So I've my test size is set again to 0.3, and I've split my data in such a way that 70% is going to my training module, and 30% is the test size. So you can see here the total size of data is around 32,000, and this gives basically these are pre-processing steps. So the total data size is 36,192 somewhat, and after tokenizing, I have Kira's model explained here. Some few of the main things which were actually done was to part sequences and test sequences, and they were later passed on with activation layers, and channel filters are set to 64, so they were passed on here. And then it was time to basically train our model with padded training labels given as the inputs, and validation dates, and epochs is set to 15 num epochs, right? So time has been calculated and just calculating the number of minutes it takes. So it's giving an accuracy of around 0.95%, which is very good. So that's it. Thank you so much. Bye.